This episode's about numerical data, and we're going to just quickly look at the two types of numerical data: interval scale data and ratio scale data. So, what's an interval scale? Probably in computing you won't have come across this, but there's good mathematical reasons for making a distinction between data that has negative numbers in it and data that's on an absolute scale from 0 with no negative numbers. Interval scale data is quantitative numerical data that's defined on a scale, and it can often represent measurements in the real world attributes. Interval numerical scales have no absolute or true 0 point. The 0 point's arbitrary somewhere in the scale, and for example, the freezing point of water is chosen as a 0 point on the Celsius temperature scale. And you can't unintuitively perhaps say that 20 degrees centigrade is twice as hot as 10 degrees centigrade, because the scale has a negative value too. So if you were comparing 20 degrees to minus 20 degrees, is that twice as warm? Is that 4 times as warm? To make that work, you would need to multiply it by -1. So you'd have to say that 20 degrees is -1 times warmer than minus 20 degrees. It doesn't make any semantic sense. So that's why interval scales are not normally used for calculating ratios. Of course, informally, that doesn't stop you saying that 20 degrees is twice as warm as 10 degrees, but you're implicitly saying in that you're not going to worry about the negative temperature scale. So here on the right is a thermometer. The temperature scale shown in degrees Celsius. 21 degrees is quite warm for England, -10 is quite cold, and 0, of course, is the freezing point of water, which was chosen, well, perhaps not entirely arbitrarily, but as one of many possible zeros that you could have for that scale. You might contrast that with a Kelvin scale of absolute temperature, and that does start at 0 and has no negative values on it. The second type of numerical data that we consider is ratio scale data. So here, this is like the Kelvin scale. It's a scale where it has an absolute 0 and there are no negative numbers. This allows ratios to be used, so you can say that if someone is 10 years old and someone is 20 years old, they're twice as old. You don't get into the problem of what if someone's minus 10 years old, because it doesn't happen. So age is one good example of ratio scale data, but you can also have height, weight, volume, price, many other things where it makes sense to start from 0. There's no negative price as such in pricing, for example, houses here. And if someone is £20 and £10 in a sale, you can normally say that it is indeed half the price. It's cheaper using a ratio than the full price for the item. In the UK right now, £1 million is quite a lot for a house, relatively expensive. Only about 3% of all houses in the UK cost more than £1 million. You can calculate an average house price in England, and that's in 2021 about £256,000, a nicely binary number. And the lowest possible is 0. You can't go below 0. It's very unlikely to find a house for £0, although you do sometimes get them in auction for £10 as a nominal fee for a house that needs fixing up in some way. Now, how do we represent those types of scales in Python and Matplotlib? So here we're going to compare a ratio scale at the top and an interval scale at the bottom. So now I'll just show you how I created those two plots. So we're just going to add Matplotlib. We're going to create some axes. So here's axes. It's drawn with an arrow symbol, and I'll just step through this. The plot axis here starts an axis for us, and in that space of that axis, we're going to draw an arrow from 0, 0 to 0.5, 0.5, with a width at the head of 0.05 and a length of 0.1. And then we call plot.show, and it does draw this arrow for us. And you'll notice something about this. We've asked for the same dimensions in each direction, 0.5 by 0.5. But on the page, you don't get the same distance. And this distorts your perception of distance versus number here. So you'll have to realize that this should be a square when it's actually not a square. And it looks like this arrow is going at a slope, which isn't 45 degrees. If this was drawn properly, it would be 45 degrees. And I want to just show you how to make that work, because not distorting data is one of the most important things in data visualization. If we want to not distort data, we add this aspect equals equal. And that means that the aspect ratio will override whatever Matplotlib is thinking about the screen space you've got, and draw something where equal units in each direction were represented by equal numbers of pixels on the page. And we'll just run that to prove it's going to work. There we go. So in this case, and these are arbitrarily scaled, we're going to get a slightly shorter in the x direction plot, but the distance, the screen distance for 0.1 of a unit in this plot is the same vertically and horizontally now. This is a very sensible thing to start with most of the time in most plots. If you don't do this, you need to give the user some intuition about how the plot's being distorted. So then the second one, so if this is a ratio scale starting at 0, the second one is going to be an interval scale which goes from minus something to plus something. So there's negative numbers in this. So here we've got the same thing as above, but now we're drawing an arrow up to 0.5, 0.5 and down to 0.5 minus 0.5. You notice I've put the interval scale on the vertical axis. The x-axis is still in essence a ratio scale of number. This vertical scale will be the one where the dependent variable sits and can range from plus to minus whatever number your data covers. Okay, so the way we've done that is just created an axis with the aspect ratio of equal, and we've set this y limit option to tell us that we want to show negative to positive 0.6 numbers. That should be covered in the slides for you, and there's a little clip from the code here to show that. I think that for now is everything on these two types of data, interval and ratio scales. Thank you, and I'll see you soon.